Greetings, we are Team 24077, Mobile Alfalfa Drying Systems, also known as MADS. I am Juliana Rios Monge, and with me are Josue Nunez, Marcos Eduardo Andrade Mesa, Miguel Lua, and Joan Hernandez Lande.
The current standard method for drying alfalfa consists of laying down swaths of it on the ground, have it dry under the sun, and rotate it after some time. For farmers, this means losing time and money. Uniformity can vary even more due to external factors, and this translates into greater prices and inconsistent quality for consumers. In this process, there is an opportunity for a new and innovative system that will allow users to obtain greater yields through faster drying while maintaining high product quality. The team set out to accomplish the vision of the sponsor, drying 4 tons of wet green chopped alfalfa down to 15% moisture level through the means of a mobile alfalfa drying system. The system consists of loading a 48 by 8 by 8 feet trailer with freshly harvested green chops and transporting it to a designated station in which the drying process takes place. To accomplish the drying, a specially designed cover system will be secured to the top of the trailer. The trailer consists of tubes that will harness and redirect heated air from an external fan system. Altogether, the drying process is completed in 2 hours, reducing the drying time by over 90% of the original time, all while being housed in a trailer that is attached to a semi-truck, ready to transport the product to the consumers as soon as it reaches the desired moisture level.
With the idea of what needed to be accomplished, our team sought out networks around our community to gain a real-world perspective on this system. These networks were forged through meetings with local manufacturers, University of Arizona personnel, semi-truck operators, propane and natural gas distributors, and suppliers from outside of the state. The communication established a clear vision of what the team can utilize to achieve the desired outcome. Communication with Shivers Manufacturing achieved an air supply system that would be capable of meeting both volume and temperature needs. In the bottom right of this slide, we can see the centrifugal fan that we were looking into. AmeriGas distributors from the Imperial Valley provided the team with relevant information to help the team make economic comparisons between the possible fuel sources of natural gas and propane. A bulk of the networking done with local manufacturers, the Berge brothers, and it was their expertise that guided the team's 3D modeling and design.
To achieve our modeling needs, the team utilized the initial dimensions presented by the sponsor to build the trailer base. What came next was a rigorous and meticulous process of creating the custom cover. The guiding question when modeling was determining the way to introduce hot air with the correct ratio of inlet and vent dimensions, presenting the best static pressure to ensure maximum drying. The proposed solution consists of a design with 6 inlet tubes that are 1 1/4 feet wide, reaching down into the mass of the alfalfa inside the trailer. Each tube is cut at a 45-degree angle, and they are also rotated 45 degrees to face in different directions in order to achieve maximum air distribution, which can be seen here on the left. The attachment to the cover has 2 slots at the top and center of the system, which can be used by forklifts to raise and lower the cover during installation or removal. All decisions were made with the guiding questions in mind, including the collaboration of our local manufacturers. The final prototype design, which can be seen on the right, ensures that the heated air flows through the product as evenly as possible, providing maximum heat efficiency for this scale model. The design also supports consistent error-free operation with minimal personnel training.
For testing, our team used a 1/8 scale of the real-world system, focusing on the 6 by 1 by 1 feet prototype model. The original 4 tons of alfalfa were translated to 30 pounds for the prototype model. To achieve a linear regression, the team ran multiple experiments to model the drying process. The weight of our simulated green chop was measured, drying it under temperatures ranging from 100 to 200 degrees Fahrenheit. Subsequently, the loss of weight was measured to account for the required humidity levels. Under this process, there are several factors, such as mean sea level or environmental temperature, that could alter the expected results. Nonetheless, testing provided data that represents valuable information for real-world applications.
Concepts included the determination of required energy, moisture loss through the drying process, and the average drying time, all to achieve the sponsored goals. Today are modeling specific factors such as the specific heat coefficient of the alfalfa, the thickness of the trailer walls, and how its material affect the drying were all used to provide an accurate account of the real-world scenario. These values allow the team to understand the required energy, which was used to determine the economic viability of the system. This viability evaluation considered the amount of energy required, converting it to needed terms. This conversion was applied to the current market to obtain the rates of the natural gas and propane.
With our system being intended for near immediate commercial use, the team had to determine the way to accomplish drying operations on site. The station is a 100 by 80 foot concrete slab with the designated areas for a drying station, forklift support, fuel station, and command center. On this slide, we can see how the team organized a real-world application through AutoCAD with depictions of where everything would be placed, with also descriptions of what each of these symbols mean on the right side. The areas were selected by considering the maneuverability and requirements for a semi-truck to position at a desired position, which was determined in consultation with equipment operators. Regulations regarding the minimum distance between fuel source and the system also was accounted for, which is why the propane tank is certain feet away not only from the command center, but also the semi to ensure safety. Swing gates and rails are used to help guide the semi-truck into position, allowing the forklift to accurately lift and lower the cover system into place. With our scale model having meet the team's requirements and presenting satisfactory figures, the team concludes that a full-scale model should be pursued. The full-scale model theoretically meets all the sponsor's requirement and will be economic asset to his operation. Design verification and validation accomplished through computer simulation and scale modeling yield an overall confidence level of 80% that the design rendered at a full scale will meet or exceed its performance requirements. Thank you.